SkySensus is a research and development project under ISED, Innovation, Science and Economic Development Canada's Industrial and Technological Benefits Policy, funded and led by Peraton Canada for the research, development and commercialization of Beyond Visual Line of Sight Technology, or BVLOS, in unmanned systems. The project includes 3 Alberta-based small businesses, along with Peraton as the sponsor. All are focused on a single vision of advancing BVLOS. Canadian UAVs focuses on the development and establishment of the detect and avoid technology through application of Sparrowhawk radar. Aerium Analytics is focused on AI, or artificial intelligence, data analytics and automation for advanced decision-making. UXS Consulting, in collaboration with Peraton, are developing an RPAS, or Remotely Piloted Aircraft System Airworthiness Certification Program for operators and technicians. Foremost UAS Test Range is the home base for the project where regulatory compliance and test and evaluation of the BVLOS enablers are proven. As a collective, the team also can evaluate concepts for RTM, or RPAS Traffic Management Services. Capability demonstrations were conducted highlighting our latest technological developments. Our first trial was held on October 20th, 2020, where 3 concurrent RPAS operations were conducted at the Foremost Test Range. These simultaneous operations have to be well coordinated to fulfill their individual data collection missions, while always maintaining air and ground safety. This deconfliction is planned in advance and monitored during the flights and is a key example of the RTM services necessary to be proven to enable BVLOS flights in controlled airspace. The 4 BVLOS enablers are under active development in SkySensus and are highlighted in the trial to show the state of technical and operational development as of fall 2020. Aerium Analytics DJI M210 quadcopter is taking off to conduct foreign object detection and runway marking analysis. Although this is a VLOS operation, this portion of the trial is designed to collect and analyze vast amounts of airport runway data to improve decision-making. Foreign object debris, or FOD, is a serious risk to aircraft and personnel at airports. This RPAS can both detect FOD and relay the information in real time. Aerium's advanced algorithms successfully analyze the imagery to detect the runway numbers for their size and compliance with regulatory requirements of Transport Canada TP 312 and FAA Part 139 post-flight. Our second simultaneous flight has begun. This is an EB+ fixed-wing unit that will be conducting OLS, or Obstacle Limitation Services Survey of the Foremost Airport. This mission is designed to showcase BVLOS technologies combined with the data transmission and deep analytics. During this flight, the RPAS was always monitored by Unifly's BLIP system to ensure safety and compliance. As you can see, when a cooperative drone goes outside of the operational zone, its status is changed to rogue. However, as soon as the drone returns to the operational area, it is once again identified as a cooperative aircraft. The data that is collected from the BVLOS RPAS flight is then transferred to our processing analytics team to complete the OLS survey. This analysis detects if there are any penetrating obstacles, like trees, power lines, buildings, or terrain along the runway approach path. The processing of this information in rapid time is a key enabler to safety at busy areas such as airports. This rapid analysis is just the initial foray into real-time data analytics that will be applied across the full spectrum of RPAS operations to improve BVLOS effectiveness and safety. Canadian UAVs has initiated the 3rd flight with their Lockheed Martin Indigo 3 quadcopter, conducting a BVLOS mission to inspect a pipeline. The Sparrowhawk radar, a Transport Canada approved detect and avoid system, is assessing their air risk for the operational area. During the mission, a non-cooperative manned aircraft enters the test area. Canadian UAV Sparrowhawk radar successfully detects the aircraft, and the radar operator is presented with an alert. Both radar operator and pilot have full situational awareness with both the UAV location and flight plan shown on the same map as a radar airspace picture. The intruder's speed, heading, and historical track are presented to aid the radar operator with the airspace deconfliction decisions, providing a visualization of the required separation from the intruder aircraft. Here, the radar operator is able to easily assess the path of the intruder aircraft, confirming that it will not present an immediate risk to the UAV area of operation, and that no deconfliction action is required. The radar operator will continue to monitor for any changes in the intruder's flight path. When a non-cooperative aircraft is detected, this signals to the operator potential conflict in the airspace and allows the team to make informed decisions regarding the operational safety. Our detect and avoid technology successfully recognized manned aircraft and other drones during the trial. The 3 simultaneous missions are now complete, and all data has been collected. Now safely on the ground, the trial has successfully demonstrated key BVLOS enabling concepts, including RPAS traffic management, detect and avoid, data analytics, and airworthiness, or safety of flight. Due to the integrated nature of SkySensus, the collection of realistic flight data will rapidly advance the understanding of BVLOS technologies and their current limitations, as well as contribute to the development of regulations and standards. Project SkySensus is a signal of growth in the unmanned aerial systems sector in Canada, providing an opportunity to contribute to economic growth and job creation. The dedication of the SkySensus team to complete this major milestone inspires the future success of BVLOS and the growth of the unmanned industry in Canada.